All right. So we talked about the first two questions. I'm going to do a couple more to get you into the habit and to maybe write down some important information, some important notes. So it's all about rewriting a statement into an inequality. Okay, question 3. A dealer can purchase touring cycles for $300 each or racing cycles for $400 each. She plans on spending no more than $8,400. This right here, listen carefully to this part. As soon as you have the no more than or up to or a capacity, that's an inequality right there. Right? You know that there's a restriction on spending. Okay? There's a restriction on spending that has been placed on this problem here. So you have to get used to letting your variables be, or assigning variables. Okay? X would be what? Touring cycles. And Y would be the racing cycles, right? In each scenario, it's number of, right? Number of cycles, right? We can't have partial. So what kind of data are we dealing with? Discrete or continuous? This is discrete, okay? Yeah. Continuous is something that continues, like you can have decimals. This is discrete. Okay? Discrete. So we are going to do this one. Basically, even if you're not sure, this is going to save you, right? It's like a set notation to say X and Y are positive. Implicit. I'm just going to say implicit, okay? It means it's not explicit. It's not being told. You're not told that. You're just assuming that that's the case. That's what that means. So now we're having 300 attached to touring cycles. So you go 300X, and 400 is attached to racing cycles. So you go 400Y. Right? That's kind of what the question is saying. Something $8,400, right? Everything has a dollar amount here. So now you just have to figure out which way is the inequality pointing. No more than. Which way would it be going? Should be going like this. Okay? Whatever cycles are being purchased, number of, right? From either one, whatever combination cannot be greater than 8,400. So it's the no more than. I will just make an arrow here. And I gave you on 48, I believe it was 48. And it is there, no more than is there on your little keyword section, right? Okay, 47. One cake requires 150 grams of flour, while a different cake requires 75. At most, 2.25 kilograms of flour is to be used, is available. So right there, that right there tells you that it's an inequality. There's a restriction on the flour that you're able to use. I'm going to say cake A. I'm going to call that the first one A and the second cake B. It just makes it easier. And so when there's a number associated with the variable, okay, use it. So what would we call X? Some of you would just say, what would you call X in this case? Cake A? Yes. Not flour, because flour is what you're using to make this, right? So cake A, and Y would be cake. What happened there? Cakey. Cake B. And this is number of. And so this is discrete as well. Number of, if you can't have partial, then it's discrete. Why is that important to identify? Because the points of intersections are going to have to be rounded later on, okay? So let's write this inequality. Oh, let's do this just so we don't forget it. They didn't ask for it, but we're just going to state it. And now we're going to go 150x plus 75y, and this has to be at most 2.25 kilograms. We have a problem there. Grams, kilograms. Okay? So every once in a while that does happen. Okay, so you have to convert. So we're going to convert right here. 2.25 kgs, right? 1 kilogram has how many grams? Do you have that on your study sheet? Should be 1,000, right? Cancel kilograms, so it's 2.25 times that, 2,250 grams, that is, okay? So that was just an aside. You can't have different units, you cannot, right? So you have to convert if possible, if applicable, I should say. So now we're talking grams, and grams, all grams, okay? Okay, so this is saying as soon as you see the 150 to 75, you're like, okay, this is restriction on flour, right? Restriction on amount of flour. Let's try this here. If I had said, maybe don't write this down just yet. I'll just do this. What is that statement saying? If you look at what X and Y is, and what would this statement be saying? Well, I don't know. You tell me, Mr. Erickson, it's Monday. This is saying that the number of cakes, right? If you add cake A and B together, the number of cakes should be less than or equal to 2,250 cakes. That's what this is saying. So these are different in a sense that here you have the amount of flour that each one needs, and then you have the total amount of flour available. This one would be saying something different, right? The amount of cakes. Okay, so this is a note. Right? This says, okay, sum of cakes at most 2,250. That's what that one is saying. I'm going to circle that in because it's not really part of this question, but sometimes having the common error is what helps us to learn. Okay, it's like, oh, you can't do it that way, right? There we go. A bakery can make no more than a total of 600 muffins and bagels in one morning. So our variables, sometimes you will have a different setup than me. You will call X bagels and Y muffins and vice versa. I tend to go with the first thing that's mentioned. That's what I go with first. And bagels. And this is number of. X and Y greater than or equal to 0. And in this case, it would just be the sum of the two combined has to be no more than 600. That's that statement right there for you. And most of the time it's discrete, okay? Can you try 6 and 7? If you already did that for homework, great, just wait for us a little bit. You can go to 42, 43 and read that already if you want, but try 6 and 7. See if you can write your own inequalities for those two questions there, 6 and 7. Kind of the same setup as I'm doing. Identify your variable, set it up, implicit constraint, and then your inequality. Okay? Give that a try. Yeah. The implicit constraint, sometimes, especially when I say it explicitly, if I say state the implicit constraint, yes. If you don't state it, you lose marks. I would always, yeah, always just state it. When it's a word problem, just state it. Okay. So try those two. Shelf, sorry. Shelves. There you have it. Those are the two last ones there. And notice that all of them had a coefficient in front of x and y other than 1. Okay, so then it's not the sum of the two is less than or equal to it. There's something attached to it, right? So in this case, it's the number of brackets, and over here it's money, right? So keep that in mind. All right, we're gonna go back a little bit. I do want to graph them because eventually we're going to come up with the inequalities on page 43. So we're just going to focus on writing for now. Okay? And I'm not going to go over the steps right now. I'm just going to tell you later. I'm going to go over the steps. But they're going to be very similar to, maybe I should just highlight it because it is important to keep that in mind. This is for word problems. How to interpret, graph, and solve a word problem. (43). A certain manufacturer makes scarves and toques. Surprise, surprise, right? That's X and Y right there. Quite often the first statement is going to tell you it takes 15 minutes to produce a scarf, 10 minutes to produce a toque. The company has up to 2 hours of production time available. Graph the solution set, state the POIs, give a possible solution. Let's focus first and foremost on this. This right here, up to 2 hours of production time available, that's an inequality right there. There's a restriction on time. Okay, there's only 2 hours of production time available to produce these. So there's a restriction on that. So let's come up with X and Y. X, Y. Scarves and Tukes. And this is the unit that we're using as we're making that many of, okay, number of. Let's state our implicit constraint, implicit restriction. Let's make a note that this is discrete. 99% of questions are going to be discrete. There might be the few that are continuous, but for the most part it's discrete. So let's come up with our inequality here. The restriction is on the time. So that's when we're going to use the 15 minutes to produce a scarf and 10 minutes to produce a toque. That has to be less than or equal to 2 hours, and that's where we have a problem, right? 2 hours is going to be 2 times 60, which is 120 minutes. Can't have hours and minutes mixed up because that's not going to result in a solution. Okay? It's not going to be correct. There's your inequality, your one and only inequality. So we're going to start nice and easy here. Set up, okay? Convert if you need to, come up with your inequality, and in this case we only have one. Guess what? We're going to graph that now. Okay? So x-intercept first. (120) divided by 15 is 8, so 8, 0. We're going to do the y-intercept. 10y is equal to 120. That's 12, 0, 12. So as I said, this part right here shouldn't take you very long down the road. We also rewrite 10y is less than or equal to negative 15x. Okay, the 15 comes over negative plus 120. Divide both sides by 10. And I'm just going to leave everything as is. I'm not going to simplify. There's going to be a solid line. True region is below. we're gonna shade above. So you got to graph this one from scratch. Look at your intercepts to guide you. This one will fit in a 10 by 10 grid. So just using a ruler. Quite often I provide you with one. And so now this is where it changes its scarves. Number of. And toques. Number of. And just come up with an appropriate scale. So I'm going to, along the x-axis, go all the way up to 8. So 1, 2, 3, 4, 5, 6, 7, 8. And over here I need to change my scale a little bit. I'm going to go 2, 4, 6, 8, 10, 12. So I'm going up by 2s here. Just make sure it's consistent, the spacing and all. So 0, 12, 8, 0. It's a solid line. Label it. You're not going to have many occasions where it's only one inequality, so I'm kind of just rushing through this one so we get to the 2 inequality scenario. True region is below, so we shade above. So you just grab your ruler. There we go. This is your solution region. And I don't know if you remember Friday, it's been a while, right? But on Friday, I introduced this notion to you that the intercepts, like the x-intercepts, or it could also be the y-intercepts, are actually now points of intersections as well. It used to be only where two boundary lines met surrounding your solution region. That's when it's not a word problem. Now we do include the x-intercepts and the y-intercepts. So we have 0, 0. This one also is 1, by the way. 1 there and 1 there. So you've got 3 POIs. Okay. So I'll just say include intercepts and origin if applicable. Okay. So if it's surrounding the solution region, if those intercepts are surrounding the solution region, whoa, what happened there? It kind of smudged it. I see. So 0, 0 is one point of intersection, 8, 0, and 0, 12. And those are going to be important to us later on, especially when we have a system. We want the points of intersection. Okay, so this is somewhat new, right? That we're including the intercepts, including the origin. Okay. And what else? It says give one possible solution. Make sure you have that on here. One possible solution. In this case, pick any point in solution region. Okay? So we could pick 0, 0. We could pick 8, 0, 0, 12, or anything in between. So I'm going to go with 2, 6. 2 and then 6. Which translates to producing 2 scarves and 6 tubes. That would be a solution. That you're not running into the problem of running out of time. Let's pick a, I don't know, I'm going to grab a green highlighter or something, right? So you can just say this one right here is 2, 6 is right there. Okay, you pick that point. That's when I just ask you for a solution. Just pick anything in the solution region. You can actually pick the line itself, including the intercepts, including the origin. Let's go to 44. This is where we're gonna practice the writing a little bit more. Writing our inequalities. Okay. Go to the middle where it says Spence, a DJ. I want you to read, and I'm kind of guiding you, I'm kind of slowly getting you into how to write inequalities, okay? I want you to read this problem, and I want you to write every single one of these bullets here is a restriction, inequality, okay? You're gonna have to go fish the right values or the right information from this little paragraph to write your inequality. And I'm gonna let you sink or swim a little bit here. So you're gonna figure it out. Make sure you use a pencil so you can erase. Read the problem, write an inequality for each one of these bullets. See if you can get that one right. And if you need to make corrections, no big deal, but make sure you write something down right now. Don't just wait for me. Write an inequality for every single bullet, okay? And if you're done, 45 has more. But for now, I'm just gonna say 44. Make sure to pay attention so you know how I go about it, okay? I'm kind of guiding you through how would you put this into a system, okay? So first, you have to tell yourself what's what in X and Y, right? So Spence is a DJ often hired to play at birthdays and weddings. Okay, so you would say X would be birthdays and weddings. And you probably think, yeah, that's number off. You can't do 0.6 of a birthday, right? Maybe if he isn't that good, then kick him out, but that's about it. X, Y is implicit, right? That's that they have to be positives. So let's see here. At most 40 hours being per week available. At most 40 hours of availability. Okay. A birthday takes 3 hours. So a birthday, I'm gonna have two different colors going here. So a birthday takes 3 hours, whereas a wedding takes 5 hours of his time, okay, including setup, cleanup, all of that. So these are the coefficients you're going to put in front of each variable. So 3 hours for a birthday and 5 hours for a wedding. That has to be less than or equal to 40 hours in total every week. Okay? So he can accept whatever combo he chooses as long as this side is less than or equal to 40. Okay? Spence would like to earn at least $2,300 a week. There's your restriction, right? The at least wants to make at least $2,300. So now you got to go up there and look for money, right? So there's a $450 fee for a birthday and $625 for a wedding. So those are the coefficients you put in front of X and Y. Okay? And earn at least, which way does it go? It goes this way. So the key words that I gave you on page 48, make sure you have a list of that on your study sheet and add to it as you go through the problems. As you come across a new one that you haven't seen before, you add to that list, okay? But this has to be 2,300. So whatever he makes with the wedding and the birthdays, right, has to be at least $2,300. You want to make more than that if possible. That much or more. Next, Spence would like to DJ at most 9 events combined. At most 9 events combined per week. This is talking about events. So that's like number of birthdays and the number of weddings. That combination, you want that to be less than or equal to 9. At most, right? At the very most, 9 combined. So no coefficients, right? So you go 3 hours and 5 hours, right? That's what we were using here. Here we go $450 and $625, okay? No coefficients, no. But by that I mean other than 1. There's always a coefficient, but it's not greater than 1. He would like to DJ a minimum of 2 weddings per week. Is this talking about both variables or just one of them? It's just one of them, okay? It's just one of them. So we're talking weddings, so weddings would be my Y variable. A minimum of 2, which way does it go? It goes this way. A minimum of 2 weddings per week, so it's just Y. All right? What kind of a line would this be, guys, if you had to graph this? It's a solid, but which way does it go? Sideways, right? It's a horizontal line. It's an easy graph, right? Define your variables. That should have been right at the beginning. Why am I putting that up down here? I'm just going to say, there. Okay. I'll tell you this, some students just want to start with inequalities and then they figure out the variables later. Like they define it later. That's fine. Okay? Sometimes they find it easier to just read it and just come up with one of these inequalities and then later making sense of it. Okay? All right. We're not done yet. One more. There's two more, but one more in class before we go. And so hold on. Change of plans because of my time. I will make page 45 your homework. Make sure you write down homework. Write inequalities. That is what you need to practice. The graphing and all that is going to take care of itself if you know how to write inequalities. Okay? So let's go. I'm going to do an example with you where I write the inequalities and then I graph it. Let's go to 49. So we're talking cakes again. Maybe I was very hungry and I made this one. A bakery has 2 cakes. Cake A requires 150 grams of flour, cake B 75. The bakery has 50 kilograms of flour available. In order to profit, oh, I should highlight that. Has 50 kilograms, that's an inequality right there. You should recognize that one gives you, there's a restriction on the amount of flour you have. In order to profit, the bakery needs to produce at least 500 cakes combined, right? Both of them together. The bakery knows that cake A is most popular and therefore makes at least 100 of them. At least 100 of which ones? Cake A, specifically to cake A. Okay? Define your variables. Let's do that. Make sure you follow along. Okay, this is it. I'm wrapping up with this. X is the number of cake A. B is number of cake B. Okay, both of them are greater than or equal to 0. What kind of data is this? Discrete, yeah. You can't have partial. I'm just going to make a note of that. This is implicit right here, so I'm going to go B right next to this part. State the implicit constraint, it's right here. Write the system of inequalities. Let's do that. Let me just go here. So C, we need to have something about the flour, right? The flour, 50 kilograms is how many grams? That's 50,000 grams. 50,000, because 1 kilogram has 1,000, so you just add 3 zeros to this, right? So we're going to go 150 grams, right, for X plus 75 grams for Y. That has to be less than or equal to 50,000. That's all that is available, so you can't use more than that. What about the next one? Needs to produce at least 500 cakes combined. That would be, right, X plus Y is less than, oh, at least, sorry. Get your act together, right? Greater than or equal to 500. At least. And the last one, specifically for cake A, at least 100 of them because they're popular. So just X is greater than or equal to 100. This is your system. System, okay? Because you've got more than one. So you've got a bunch of restrictions happening here, and we're going to now graph that. So let's graph it. Let's do each of them separately. So you've got 150x. Let's find the intercepts. So this is where I should go a little faster. Let me just look for that page. This gives you 333.33. Y is going to be equal to 666.67. There are your intercepts. That's for graphing purposes. Let's rewrite it. So I'm going to go 75y is by itself. The 150 comes over, subtracting. Divide both sides by 75. 150 divided by 75. That is actually a nice round number, so I'm going to actually go -2. And here's where you have to be careful. Is the y-intercept a finite decimal? It's not. So please just leave it. I know this is annoying. It's not, doesn't look pretty, but we're going to leave it like that. Not finite. Leave as fraction. Let's just do the three pieces that we always want. This is solid, of course. A true region is below. We're going to shade above. Just circle the shading part. That's probably the most important piece that you want at the end of the day, shading. The other one, the second inequality, you're going to love that one, the x plus y, because it's just 500, 500. So I'm going to break this off here. X plus y is greater than 500. X-intercept is 500, 500, 0. And y is 500, 0, 500. Let's rewrite it. X comes over subtracting, and the 500 is already there. I'm going to clean up the intercepts like this. Oh boy. My bad. Okay. Make sure you write those inequalities, please. And can you finish watching this lesson at home? Probably 5 to 10 minutes. And I'm going to tell you which one I want you to try like this. Okay, so just watch the lesson so you'll know which one to try. Okay? Because writing the inequality shouldn't take you very long. This one does take you long. Okay? So I want you to practice at least one of these when you come in tomorrow. It's the last week, guys. Work hard. All right, so we'll finish this lesson here. We rewrote this one.
Are we almost done?
All right, so we rewrote it. Now we just need to say that it's going to be solid. True region is above. Okay. We're going to shade below. Very important. And right next to it, I'm going to do the other special case. Very easy to graph, right? That's a vertical line through 10, 0. Okay? It's going through there. A solid. True region is to the right. We're going to shade to the left. All right, so that's everything I need. I have all three inequalities rewritten. So just like before, you graph each one individually on the same grid. Okay. So we look a little bit at our x-intercept, so big numbers, but don't worry about it. We're just going to use a scale that makes it work. But I've got, in terms of the y, as high as, almost 700. X is 300. I've got an x-intercept of 500, so I got to make sure I include all of that. Sorry, and this is, I just noticed a mistake. This is 100. Good thing I caught it. Right there. So let's graph this. And still fits. You just have to use a scale that makes it work. Okay, so I'll just call this cake A, and the unit is number of. Okay, cake B, number of. And I'm going all the way to 500 here. We're making sure at least I can fit that in. So I'm going to go 100, 200, 300, 400, 500, and I'm going to keep going a little bit all the way to 800. So if you just label every other one, that's going to be just fine. And then we have our Y. I need to make sure I go all the way up to 700 or so. So let's see here, 100, 200, 300, 400, 500, 600, 700. That works just fine. I'm also going to label every other like this. And now you just plot, right? So 666 is right there. 333 is right there. Just connect it. Label it right away. 150x plus 75y is less than or equal to 50,000. And I'm going to graph the next one, which is 500, 0, 0, 500. There you have it. And the 100 line, which goes right through here. It's just a vertical line. And that one you can have an arrowhead, right? This is the x is greater than or equal to 100 line. So remember, do not go into the negatives on either the y-axis or the x-axis. And now we're going to shade the false regions so we can eliminate them. So for the first one, it's shade above. So this is my first line. Got to make sure you don't mix them up. So just light. Okay, and then the next one, it's shading below this diagonal line here. And one more thing is, if you compress this too much, then sometimes the solution region is almost invisible or too small. So you gotta watch out. There, and for the vertical, I'm shading to the left. So you're shading this little wedge here. Essentially getting rid of that. Okay, so all of that is gone. The only area that has not been shaded is right there in that little triangle in this case. Sometimes we call that the solution polygon, because sometimes, like, it could be that this region right here could have been the solution if I had just worded it differently. So you've got many different regions all around here, kind of closed off by the boundary lines, but the only one that hasn't been shaded is that one, which means it is true for all three inequalities. That is where the true region is. So we call that the solution region. So I'm just going to go arrow and just call that the solution region. All right. So we've got that figured out. Let's figure out a possible solution. We'll do that in a bit. We'll just do F here, figuring out the points of intersection. So this is where you need your graphing calculator and you need to type in the all the equations properly. So you need to make sure you do that carefully. So negative 2x plus, and I use brackets for this. And remember, I do this because it's not a finite decimal. Then you go to the next one. It's negative x plus 500. Then you go to the next one, which is just, that's a vertical line. So that's 1, 2, 3 nines, another 3 nines, another 3 nines. So it's 9 nines followed by x minus 100 in this case, because it's 100 positive here. And so then you go ahead and graph it. And it's not going to work because my x and y axis need to be extended, right? So I'm going to go x max. I'm going to go to, I think if I go to 600, I'm fine. So 600 for x max. My y max, I'm going to go all the way to 700. And make sure your x min and y min stay negative, right? So if you want to just go a flat negative 5 and a negative 5 there. There you have your 3 lines, and it does look like what we have over here. And again, always check, right? Does it make sense that my line is going down when I plot these points? And then you look at your slope, and it's true, right? It does go down. Things like that, always check for things like that. So let's go ahead and find the intersection here first. So second trace 5. And it's just, you got to make sure you select a point on the blue line and on the red line. In my case, it jumps to the red line right away. So there is the first one. That would be 166.67, 333.33, okay? Next, we're going to find this one here. So between the red and the black. So second trace 5. I'm going to jump to the red one. Select, and then it jumps automatically to the black for me. So I'm just going to hit enter there and enter one more time, and it is 100, 400. I'm going to find this one too. I can already tell that it's going to be 100, right? Because this is the 100 line. So it's going to be 100 something, right? So blue, I'm going to select that, and then I'm going to jump till I get to the black line and hit enter, enter. And there it is, 466.67. Okay, so you've got your 3 points of intersection right there. And this is where the discrete comes in. You want to round, right? Discrete. So you need to round. So you just round up or down. I don't really mind either way. Just follow the rounding rules. This is already 100, 400, so that stays. This one we need to round as well. And there you have it, right? So the points of intersections that are acceptable in this case are those 3 right there. Surrounding the solution region, right? The boundary lines are surrounded. So in this case, there are no x and y intercepts to be included. Every single one of them had to be found using your calculator. And so that's where I want to go back to a possible solution. All these here are a possible solution for sure. So in this case, I'm just going to pick one from there. Sure, you could have gone, right, and picked one from that region, but that's a little tricky because if you're off, right, if it's wrong, then you don't get the marks, right? So I'm going to grab this one here because it didn't involve any rounding. I'm going to go 100, 400. So that means that making 100 cakes, type A cake, and 400 type B cakes, I should say. That is a possible solution. And I'm just going to go arrow and kind of indicate that I use this. So 100 cakes A and 400 cakes B. So now we have a context, right? So we have to kind of indicate that. What else do I need to mention about this? I think so far that's all I need to say. And so the questions I would like you to try are found, we're going to skip a few pages. If you are following, these questions right here, we will deal with them later. I will for now skip that and just ask you to go to 57, I believe. Yes, 57. I want you to try 57 at the very least, so at least one, okay? If you're stuck, there's a QR code that walks you through the question. First, try it by yourselves, okay? The first and foremost, like the most important part of these types of questions, of the word problems, is to actually write out the inequalities and get them right. Then the graphing and all that follows. So for now, I would like you to first focus on writing the inequality for this one. Then I want you to try to write the inequality for 58 as well. And for at least one of them, make sure you actually do the whole solving part where you actually graph it and so forth, okay? Just like I did with you on the previous example here. That's it, that's all. Thank you.